We are continuing through the 1-2 notes for AP statistics, and we are looking at graphs that are appropriate for quantitative data. On the previous page, we looked at a stem and leaf plot, but the stem and leaf plot didn't really show much of a shape. So I took the same data, and if you recall, the data was about people waiting in line at an amusement park. I took that same data and I put it into Minitab, and I let Minitab make the stem and leaf plot. So there's a couple things to show you here. All right, let's ignore these things right now. And all I want you to look at is, imagine there's a vertical line right here. There's your stem and leaf plot right there. These are your stems and these are your leaves. And it's called a split stem because there's not just one row for the ones or the twos or the threes or the fours. There's two rows for each. And how they're split is the leaves get split on the top row are leaves that are 0, 1, 2, 3, or 4. So there's 5 potential values for leaves. And then the next row is anything with a 5, a 6, a 7, an 8, or a 9. So if there were 15 people waiting in line, right there, 15. If there were 14 people waiting in line, which there weren't, but that would have been right here. 10 would have been on this row. Don't make the mistake. A lot of people automatically assume the first row goes up to 5 and the second row goes up to 10. No, it has to be 0, 1, 2, 3, 4, and then 5, 6, 7, 8, 9. So they each have 5 potential digits for their leaves. Now, what the split stem does, and by the way, Minitab does this without even asking. It makes the most appropriate graph that it can come up with. But what this graph now shows me, the one the previous page didn't, is these potential outliers right here. If I turn this sideways like I did the one on the previous page, I definitely can see that unimodal, and I can definitely start seeing that right skew. So I would describe this distribution by saying it's right skewed, and there's a gap in the early 40s, and there's 2 potential outliers. So 2 rides must have been really popular. There were 2 rides that had 46 or 48 people waiting in line. The longest line before that was only 38. This gap was not apparent until we split the stems. Notice Minitab also gives the n size. That's how many people or how many rides we were looking at. All right, let's talk about this other stuff. Pay attention how Minitab conveys the key. All it does is describe the leaf unit. Remember, these are the leaves right here. So they're telling you that this stands for 6.0. This stands for 9.0. So if these are the ones place, then you know over here the stems must be the tens place. So this is telling you all of these are in the ones place. Therefore, these must be in the tens place. Now, what are these numbers over here? These are actually cumulative frequency amounts. And what happens here is on the first row, there are four leaves. That's what that 4 is. On this next row, there are 10 leaves. Well, these 4 plus these 10 make 14. On this row, there are 7 leaves. So why does this not say 21? Well, let's work up from the bottom. On this row, there are 2. On this row, there are 0, so we still have 2. Plus 3 more makes 5. Plus 4 more makes 9. Plus 5 more makes 14. Plus 7 more makes 21. This, when you see this little parenthesis right here, that is Minitab's way of saying your median is in that row somewhere. Okay, your median is happening in that row, and we'll talk more about that in a different section. But just so you know, if you're just looking at a stem and leaf plot just to see the graph, you actually don't need those numbers from Minitab. So the final example here says, describe the distribution shown above. As your book says, don't forget your socks. Remember, we have shape, spread, center, and they say O for outliers, but we want to talk about extreme values and any unusual features here. Another hint, use words like roughly or approximately generously whenever you describe a distribution. Remember, it's rarely going to be perfect. So the first thing I would say here is I would talk about, I actually like to talk about what does the graph show. The graph shows number of people in line for rides at a park. I like to start by saying, what is the graph actually showing? Almost like what your title would have been. So now you can address your socks in that order. It doesn't matter. I generally talk about shape first. So I would say that the distribution has a right skew with several extreme values at the high end. Now, as it turned out in that one sentence, I have now addressed my shape and my unusual features of my extreme values. I did that all in one sentence. So in some ways, I could say I already did S and O. A typical line at this park will have about, and this is where I might address center, I would say anywhere from about 15 to 20 people. And basically, you're kind of coming up with that idea of where the median is. But I'm looking also because we had this peak here. So I said, I'm expecting 15 to 20 people. Getting more than that, there's not as many. So really what I addressed there was my center. So I have done shape, extreme values, center, and spread. Some lines have as few as 11 people, but most lines have at most 38 people. And I'll even say, except for the 2 extra long lines with 46 and 48 people. So what I've done there is I've addressed the spread, but I also made sure to emphasize again that in general, I'm expecting from about, let's call it 10 to 40 people. And then anything above that, even though technically it's part of the range here would have been 37, from 48 down to 11. But those were kind of odd. Most of the rides have between 10 and 40. And then there's a couple of rides that must be super popular. Don't think of it as just stating facts, but try to put it, think about if you were writing a paper for an English class or writing an article in the newspaper about this amusement park. You don't have to state it just, fact by fact by fact. Just write what you see, okay? So the last thing here on Stemplots, we have what's called a back-to-back Stemplot. Now the back-to-back allows you to compare only 2 distributions, where if it was a dot plot, and I'm just going to flip back in the notes here, if you have the scales the same, you could stack a whole bunch of dot plots here. I only did restaurant A and B, but you could have had restaurant C, D, E, etc. And when you do a stem and leaf plot, you can compare at most 2 at a time. Now, what you have to remember when you do this is, when you look at it this way, that's just like a normal stem and leaf plot. So this one, I might say, has a slight left skew, actually. On this one, you have to read it backwards. So these are still your stems, and these are your leaves. So if this is minutes of music, we have 29, 31, 38, 46. You have to read it backwards. And when you put it in order, you have to put it in order backwards, from smallest to biggest, from right to left. Where over here is from smallest to biggest, from left to right. Okay? Still make sure everything is stacked nice and neat, because again, you should be able to turn it sideways and say, oh, look, there's a slight left skew. Oh, look, this one actually has a cluster a cluster, and there's a little gap right here, okay? They should have the look of a bar graph if you turn them sideways. Notice the key up here also. Stemplot summary comments. They are easy to create with small n sizes. You can see data values, but they might be rounded, but they will be in order. You can compare two at a time back to back, and you can definitely see the shape of the distribution, including those interesting things like gaps, clusters, and outliers. And I said consider splitting stems if you can't see it right away.